Hi, and welcome to Mike's Garage. So today we're going to do a quick review of this inverter that just came in. Now this is a 12-volt inverter, 1200 watts continuous, pure sine wave. So this was sent to me to do an honest review, and that's what you're going to get. So we're going to look at the specs real quick. We're going to open it up. Then we're going to connect it up to a 12-volt battery, do a load test on it. Let's see if it does what it claims to do. All right, so this inverter does have soft start technology in it. Which is good. It has a lot of protections on it, low voltage, over voltage, short circuit on it. It does do a pure sine wave output, 1200 watts continuous. Not sure on the peak. It doesn't list it in here, but we'll see how far we can push it. Not too much in the manual as far as the specs on it. So let's go ahead and open it up. Let's see what's on the inside. All right, so it does look like your standard high frequency inverter. Does have a small little transformer in here. See, it's got a choke there. Looking at the outlet on it, does say that the outlet is UL listed. So that's actually good there. It has two fans. Let me check these terminals real quick. All right, those are tight. Looking at the power cables on it, it does have two 8-gauge wires, and then for the ground, two 8-gauge wires is what it appears to be. Here's something that's interesting. I don't know if you can see this here. Let me lift it up. The fuses are actually on the inside instead of the outside. I'd recommend changing that. Put the fuses somewhere else. Having them on the inside with it not being user serviceable is not a best practice. So recommend changing that. You can see that, you know, you got the power cable going in between the fuses there. So I'd recommend changing that. You can see a lot of the connectors are glued, which is good to see. I do see that it has a temperature sensor here. You can see it's mounted on that heat sink. I'm guessing that's to turn these fans on. So looking at the fans, there's two wires to each fan. So they're not variable fans. They're either on or off. And the mounting of the MOSFETs looks good. I like the heat sinks. Looks like they're held on pretty good. This is interesting. So on the board, it says the capacitor is supposed to be 100 UF, 450 volt. But I'm seeing 250 volt, 260 UF. And then same for this one here. I don't know if they changed design on it. 100 UF, 450 volt. But on the caps, you can see that they're 260 UF, 250 volt for those polarized electrolytic caps. So what we're going to do, we're actually going to power this thing on, see how it does. I know if you have the top on it, it's going to improve the airflow. But I just want to kind of take a look. It looks like, once again, these cables here appear to be undersized. But what we'll do is we'll fire it up. We'll start load testing it. We'll see if the cables get hot. I mean, I'll keep an eye on the temperature here of the heat sinks to make sure there's no issues. But I want to kind of see that. I mean, these cables here probably could use to be thicker. Let's go ahead. We'll hook it up. We'll see what it does. The battery that we're going to use today is by Greener Power. You've probably seen a review on this battery before. I do have a fuse on it up on top. So this is a terminal style fuse. This one is 150 amp. Just in case, it's always good to have a fuse. All right, should have the screen power on. All right, so as you can see, our voltage, we're sitting at 13.1 volts on it. The output's 122, 0 watts right now. You can see the battery's fully charged. All right, so what we hooked up is an old Arvin heater. So this will do 1,000 watts, 1250, and 1,500 watts. So as you remember, this will do 1,200 watts continuous. So we're going to check that out. So we're going to start it at 1,000 watts first. You can see the fans kicked on. So what we're going to do now, so we're at 81 degrees there. Looks like the wires are 87. Okay. So far, so good. Let's go up to 1250. You can see it start to glow from the heating element. I actually just move this off to the side so it's not blowing on the inverter. So you see the current load right now is 1,135 watts, and it's holding it pretty well so far. Heat sinks are fine. At around 90 degrees Fahrenheit right now. Check on the wire. So you can see the terminal's at 82 degrees, but then you look at the wire is at 120 degrees. Like I said, you're going to want thicker wire. Let's check this wire here. So we're at 113. Versus 126. All right, so the next thing that I'm going to do is I'm going to put this on 1,500 watts, but before I do that, let me actually put this cover back on. Let's see if it'll hold 1,500. This is going to be over capacity. As you can see, these are glowing. So right now we're at 1280. Now it's saying that the battery is low, but the battery itself isn't low. What's happening is this thing is starving because of the voltage drop, not only for these wires that are right here, but the wires on the inside. So it's hitting 1,266 watts when it should be at 1,500. It just can't put out anymore. Oh, I'm seeing smoke. All right, so I turned it off. Let's check the temperature of these wires. (171 degrees), 172. Let's see if the ground. (173). And the heat sink was 104. So, as I said, thicker wires there on these terminals. That's a must. All right, so a real quick summary on this. So the unit did perform as expected. It did put out 1,200 watts continuous of 120 volt output. So that is good. I would recommend that the vendor do a couple things. Number one, move those fuses to the outside, make it user replaceable. Next thing that you're going to want to do for the case, maybe redesign it a little bit to make it easier to take off and put back on. Now, I realize that it says right in the manual that it's not user serviceable, but with having the fuses on the inside, it makes it user serviceable at that point. The other thing for the wire, so definitely recommend thicker wire on the outside, but even more for the inside. The current gauge wire is not quite thick enough for the amount of amperage that's going to it, and that's why we saw the high temp of 172 degrees on that wire. So that's my review. Like I said, it does work. It didn't give me any performance issues, but just recommend that the vendor make those improvements. So that's it. Thanks again for watching Mike's Garage.